All right, everyone. Going to go over some slides for lecture on this section of our textbook, 7-2. Notice these slides are based on our textbook, but they are based on a later edition, which will all be fine because it's a bunch of the same content and can all still be used just as well. So again, this section is section 7-2, estimating a population proportion. This is going to be using an idea called confidence intervals, which you'll get to see some examples and hope to understand what those are after these videos here. So just remember, at any point while watching videos, you can pause them to finish taking notes, write down definitions, maybe attempt examples on your own first, whatever you feel you need to do. And you can always rewind or rewatch segments into your heart's content, so you feel like you have a solid grasp on everything. So some key concepts of this section include that the sample proportion is the best estimate of the population proportion, which hopefully that should be a bit of review in a way. And next key concepts, are probably the most important one, is that we can use a sample proportion to construct a confidence interval to estimate the true value of a population proportion, and we should know how to interpret such confidence intervals. So, and just kind of highlighting, we're going to be constructing confidence intervals to estimate population proportion values, and we're going to interpret those confidence intervals. Will be some of the most important stuff of this section. And last key concept is just that we should know how to find the sample size necessary to estimate a population proportion. So I'm going to start right away with an example here, actually, and then dig into where everything's coming from in this example after. So in a Pew Research Center poll, 70% of 1,501 randomly selected adults in the US believe in global warming. Construct and interpret a 90% confidence interval for the true proportion of US adults who believe in global warming. So that was a typo. How you go about finding that is 0.7 plus or minus 1.645 times the square root of 0.7 times 0.3 divided by 1,501. Now, see, the 1.645 times everything in the square root, that ends up being approximated to about 0.019. So to finish doing the confidence interval calculation, you just do 0.7 plus or minus 0.019. So after doing the minus part, 0.7 minus 0.019, you get 0.681. And 0.7 plus 0.019, you get 0.719. So then that's your finished confidence interval answer in that parentheses notation, or you can always give your answer in inequality notation like that as well. Then as for the interpretation, we can be 90% confident that the true proportion of US adults who believe in global warming is between 0.681 and 0.719, or between 68.1% and 71.9% if you want to say it as percentages. Now, of course, you're probably wondering now, where did all of that just come from? And that's what I want to dig into now, is how I was able to come up with those numbers and just kind of how I can use the confidence interval. So as for where all the numbers were just coming from, ultimately I was plugging everything into this formula right there, which is the confidence interval formula. Notice started with a 0.7 for p hat, so that was that sample proportion, plus or minus a 1.645, which is where the z sub alpha over 2 was. Now that's called the critical value. And then just plugging in 0.7 for p hat again inside the square root. And to calculate 0.3, and then plugging in 1,501 for the sample size, all of that inside the square root. Now I just evaluated that, and that's how I got my confidence interval answers. And again, just reemphasize what those numbers are. P hat is that point estimate, or sample proportion each time for these types of confidence intervals. And then that z sub alpha over 2, that's the critical value. Now, this is one name you won't need to worry too much about defining such, but I want to let you know what this piece is. Everything inside the square root right there, that is the standard error. So all of the square root of p hat times q hat divided by n, that's all the standard error. And then together, the critical value times the standard error, that's what makes up the margin of error. which that's a more important part of understanding so that you know what to use for a confidence interval. So again, those are just what those pieces of the confidence interval formula are. And then I'm going to go on from there to define a confidence interval, and then kind of dig into each of those pieces so we can see how it all comes together. So to define a confidence interval or an interval estimate is a range or an interval of values used to estimate the true value of a population parameter. So just key things there is, again, it's an interval of numbers and then used to estimate some population parameter. So still just getting along with the idea that in statistics, we take things from a sample to estimate or learn things about a population. And just know sometimes confidence intervals, they can just be abbreviated as CI. So now I'll start looking at different parts of the confidence intervals and then just how we come up with those. Now, and so first part is just in that point estimate, which in that formula, that's just p hat right there. So the point estimate is a single value or point used to approximate a population parameter. And so in the case of this section, the sample proportion is the best estimate of the population proportion. So p hat to estimate p. And so from our example where the Pew Research Center, 78% of 1,501 randomly selected adults in the US believe in global warming, our point estimate p hat is just 0.7 from the 70% right there, since that's our sample proportion. Now, something else we're going to need before I start defining other pieces of that confidence interval formula is the confidence level right here. Now, how you define that is the probability 1 minus alpha, often expressed as a percentage value, that the confidence interval actually does contain the population parameter, assuming that the estimation process is repeated a large number of times. This can also be called the degree of confidence or the confidence coefficient. So just key things to highlight there is ultimately, just remember, it's a probability, and it's often expressed as a percentage. So now from that first example, the confidence level is in fact that 90%. Is what I'm saying, construct a 90% confidence interval. That's going to be the probability that my interval does actually contain the true population parameter. Because that's ultimately what this definition is getting at, is the probability that your confidence interval does actually contain the true population parameter. Now, biggest thing here is that is the probability that your confidence interval contains the true population parameter, assuming that you do the same estimation process a large number of times. So say with that first example, if I got many different samples of 1,501 adults and made some confidence intervals from each of those samples, then 90% of the time, my confidence intervals would capture the true population proportion. Now, the most common choices for confidence levels are 90%, 95%, and 99%. Definitely, I would say that 95% is the most common one for sure. And other thing just with this definition here is notice each of these do correspond with an alpha level. Now, these are just kind of the leftover percentages because we can't say with 100% confidence that our intervals will contain the true population parameter each time. So the leftover I've got is 10% or 0.10 for 90% confidence intervals. I've got a leftover 5% for 95% confidence intervals, and then 1% or 0.01 for 99% confidence intervals. I'm going to use that idea of confidence levels here to help define what the critical value is. And actually, I'm going to go ahead and stop here and then save that for the start of the next part of these videos, just for defining critical values. Okay, so I'll pick up in just a sec.